Hey, what's up everyone? This is an Algebra 2 final review, and this review was given by Professor Gwynn, and he is a COS professor, College of the Sequoias professor, and I'm doing this just to help out some of my students. So I have some students who are taking some vacations and stuff before the final, and this will give them something to look back on to be able to study for their final and hopefully get a decent grade. Okay, so check it out. This is the very first problem. Okay, so we have here x plus 7, x minus 2 divided by x minus 5 is less than or greater than 0. Okay, so when you see something like this, the very first thing you got to do is you got to find what's called your critical numbers. Okay, your critical numbers. Okay, and how you do that is, as long as this is factored, okay, and in this case everything is factored here, as long as it's in this kind of form here, you just take each one of these guys and you set it to 0. So you got x plus 7 equals 0, x minus 2 equals 0, and then x minus 5 also equals 0. Okay, so then you just solve each of these. You got negative 7, subtract 7 from both sides, x equals negative 7. You're going to add a 2 to both sides here, x equals 2, and then you're going to add a 5 here, so x equals 5. Okay, so these are your critical numbers. So now what you do is you're just going to draw a number line. After you find your critical numbers, you just plot them on here. So we got 3 of them. And all you got to do is make sure they're in order. So negative 7 is going to go first, then it's going to go 2, and it's going to go 5. Now, when you have a fraction here, when you're doing this type of problem and you have a fraction, it's very important to note the critical number you find from the denominator here. Okay? In this case is 5. Whatever critical number that you get from the bottom here, because you can never ever divide by 0. That being said, if you stuck this 5 here, 5 minus 5, that's 0 in the bottom. That being said, this always has to be open. It's an open circle because x cannot equal 5, okay? So whenever a fraction, whatever critical numbers you get from the bottom, just, make sure that that guy's open. Now, the other two critical numbers are included, okay? Why are they included? Because right here you have this equal to, it's less than or equal to 0. Okay, so now what you got to do, after all that's done, you have to pick a test point. You're going to have to pick, points between each one of these intervals here, okay? So what I teach my students is I say, okay, over here you got to pick a number that's, in this bracket here. So anything on the left, negative 7, so negative 8, negative 9, negative 10, etc. What I do is I test negative 100. The reason I pick that is because it makes it very obvious what we're doing here. Once you pick negative 100, see what you're doing is you're testing just this section here. You want to see, is this section going to consist of negative values, values that are less than 0 or greater than 0. So you're just going to stick negative 100 into here, and you don't have to physically stick it in. All you have to do is basically say, if you stuck negative 100 into x, what number are you going to get overall? Well, negative 100 plus 7 is obviously going to be a negative number. Negative 100 minus 2 is going to be a negative number. And then negative 100 minus 5 is going to be a negative number. And that's why I picked negative 100, because it's so large that you can easily tell. Okay. That being said, we got 3 negatives here. An odd number of negatives is always going to be negative, because negative times a negative would be a positive, and then we're left with 1 negative left over. So what that's saying is from negative infinity to negative 7, it's in a negative zone here. Now I'm going to give you guys a little hint. It's always going to alternate like this: negative, positive, negative, positive. Now, okay, so I have to protect myself here. It's not always going to alternate, but for your class, it should. Okay, for your class, every example that you get should always alternate. And if you don't believe me, just go check them, and I assure you they're going to alternate. Okay, so I know this is a long problem, still not done. Now, once you get your little symbols here, where it's positive and negative, you just go back and you look at this symbol here, the very first symbol. And it says that this thing has to be less than 0. So, what kind of numbers are less than 0? Negative numbers. So what you do is you go back down to your diagram and you just bubble in wherever you have a negative. Okay, cool. So then your very final step is just write it in interval notation. So you got to start left to right. So you're starting off at negative infinity, and you're going boom to negative 7. Negative 7 is included. Then there's a gap here, so you got to do union. You're gapping over to 2, which is included, and you're ending at 5, which is a parenthesis. Boom. And that is how you do number 1. Alright, so the next problem for this review. So I have to make a correction here. The review apparently doesn't say number 1 here. It says number 3. So I don't know if I'm missing problems in 1 and 2. But any case, this is number 3. I'm just going off of the review that that we got here. Okay, so you can see it says number 3. Okay, so next one, number 4 apparently. We got this guy. 5 square root of 20 plus 3 square root of 125. Okay, and the directions are just going to be simplify. Okay, so you're going to simplify this guy. So the first thing you got to do is you got to break down these square roots here. Okay, and how you do that is you just do this little tree here, and you say what two numbers multiply to 20. And it can be any combination. So we can do 5 times 4. Okay, and you break it down until you can't break them down anymore. So 5 you can't break down, 4 you can though, into 2 times 2. So since this is a square root, when you break it down, you're going to look for groups of 2 and put a little dash there. That little dash is just representing one of those 2's is going to come out. So how this first guy is going to break down is we're going to have 5, and then a 2 is going to pop out times the 2. And then what are you going to be left with inside this radical? Well, there's just a 5 left over here. So that 5 stays inside. Okay. So you have plus, you got to break this down. This is going to be what? 25 times 5. And 5 is going to be 5 times 5. And that, again, we got another group of 2 here. Okay. So we got this 3 that's already out there. You're going to pull a 5 out. And then what are you left in? 5. And the reason we do that is because now in the back we have a square root of 5 and a square root of 5. Now you can combine them. Up here you can't combine them because what's inside the square root has to match, okay? And that's what we broke it down to, and they match now. So you just finish it up. So 5 times 2 is 10 root 5 plus 3 times 5 is 15 root 5. Now it's just like saying, you can just say this is kind of like 10x plus 15x. So it's just going to be, what's 10 plus 15? It's going to be 25. And you just carry that root 5 there. Okay? That's number 4. Problem number 5. Okay? So we got this guy here. So what you're going to do is you're going to basically distribute, or you may know that as FOIL. I don't really like that term too much, but or that acronym really. But yeah, we can. We're going to FOIL this guy, distribute. So what I like to do is it always helps me if I draw these little lines. So it's the first guy times that one, and it's the first guy times the second guy here. Then you got this times this, and this times this. Okay. So what you got to do here is we're going to start with this guy times this guy. Okay. Well, 10. So you always multiply the numbers and then you multiply the roots together. So 10 times 9 is going to be 90. But then we're going to have, okay, so now we have a square root of 5 and a square root of 5. Whenever you have a square root times the same exact square root, in this case square root of 5 times square root of 5, you're just going to end up with what's inside. So the 5 to them, boom, pop out, okay? Alright, so now we gotta go move on to the next guy. 10 times 2 is a positive 20. Now we have square root of 5 times square root of 11. So what you do is you just multiply the inside. So 5 times 11 is 55. And you just have the square root of 55 there. Okay. Now we're going to have this guy here. So negative 7 times 9 is going to be a negative 63. And then again, you just multiply the insides of the roots here. So 11 times 5 is 55. And then we move on to the next one. Negative 7 times a positive 2 is going to be a negative 14. And then, so what happens here? Okay, it's square root of 11 times the same exact square root. The inside just pops out. Alright, so we're going to have to do some simplifying here. So that being said, what is 90 times 5? And I'm pretty sure you're allowed to use a calculator, so you can just, pop that guy in there. I don't have mine on hand at the moment, but that's going to be 450. Actually, I apologize, you guys can't use your calculator. So with that being said, just do it off on the side. One trick you can do, how I did it in my head, was 9 times 5 is 45, and then you're just going to add the 0 there, so it's 450. But without a calculator, you just go 90 times 5, work this guy out, 0 times 5 is 0, 9 times 5 is 45, and you get your answer, okay? So don't knock off just doing it off the side, because that really helps. So now, these guys are like terms. So you're just going to basically do the numbers. So 20 minus 63 is going to be, what is that, negative 43, and then you just carry the root because they're like terms. Now, you have negative 14 times 11. And this guy, I am just plopping it into a calculator. I just opened it up on my laptop. And that's 154. And again, because you can't use your calculator, obviously, I'm just trying to, make these videos not ridiculously long. You can just do it off to the side, and you should get 154. Okay. Now, these guys are the last things that are left to combine, because these are just numbers. So we have 450 minus 154, and that is going to equal 296. So we have negative 43 root 55. I'm just carrying this guy down, and then we have plus 296. And that, my friends, is how you do number 5. Okay? Again, all this little work and stuff, just do it off to the side. If you have to subtract these, just line them up. And, you do 450 minus 154. Just subtract it, and you'd be good to go. Alright, on to number 6. Alright, on to number 6. Alright, so when you see something like this, where you have a square root on top and a square root on the bottom, you can rewrite that guy with one square root, and you just basically put this stuff inside. So you got 224 x to the 5th divided by 2x, okay? And once you do that, you can start reducing some stuff in here. So we have 5 x's on top and 1 x on the bottom. If you just have x, it's really like x to the 1. So what you do is you just subtract this. So basically 5 minus 1 is going to be 4, and you're not going to have this x on the bottom anymore. And then what you're going to do is you can reduce these numbers here, okay? So 2 goes into 2 once, and 2 goes into 224 112 times. And again, if you can't do that in your head, just go out to the side and divide it out, okay? Alright, so what do we have now? So now we just have the square root of 112 x to the fourth. Now, on the bottom, everything canceled off, so it's really divided by 1, but we don't need to really write, anything. When anything's divided by 1, you just kind of don't need to write that, okay? So now what you're going to do is you're going to break down this this number here, just kind of like we did in one of the previous problems. So 112. So what you're going to do is you're going to start off by dividing that by 2, okay? And so you're going to have 56 times 2, because 56 times 2 is 112. And then you're going to break that guy down again by 2. And you're going to have 28 times 2. And you break this guy down, and it's going to be 14 times 2. And then you can break down the 14 by 7 times 2. Now, it's a square root, okay? So there's like an invisible 2 there. It's always a little invisible 2 for a square root. So what you do is you're going to go and look for groups of 2. So there's 2 2's there, and there's 2 2's there, okay? So what happens is 2 2's will pop out of that square root, okay? So what you're going to end up with is you're going to have 2 times 2, and then you'll have the square root of, now what's left inside? We just got a 7 here, so root 7, and we'll leave our x to the fourth in there for now, okay? Now, 2 times 2 is 4, so you have 4 square root of 7, x to the fourth. Now what you're going to do is you basically say, again, this is a square root, okay? So how many groups of 2 can come out of a 4? You basically just count by 2's. 2, or 2, 4, twice. So 2 x's can come out. So what you're going to be left with is you're going to be left with 4x squared, that's from this guy popping out, root 7. And that is your answer for that guy. Alright, good news. So my review is a little bit mixed up. So I actually found number 1. So if you recall, the very first problem we did was number 3. So we're going to backtrack to number 1. And yeah, let's do that. Alright, so because I don't want to miss anything on this guy. So we have the absolute value of x plus 3 equals 5, okay? And apparently there's 2 problems here. We also have the absolute value of x plus 3 is less than 5, okay? So I'm going to show you how to solve each of these. So these are 2 different problems, but one has an equal sign, one has a less than symbol. Okay, when you see an absolute value like this with an equation, what you're going to do is you're just going to make 2 equations now. So you're just going to say x plus 3 equals 5, and then you're going to say x plus 3 equals negative 5, okay? So you just remove the absolute values, and you say x plus 3 equals 5, and then x plus 3 equals negative 5. And then you just simply solve each one. Negative 3, x equals 2. That's one of your answers. And then you just solve this guy. Boom, boom. X equals negative 8. And that's that guy. That's done. You're done, okay? So try not to overcomplicate it. Now, in this case, when you have an inequality here, okay, all you have to do is the first thing is you're going to rewrite it with the absolute values gone. Now, this symbol here, you're just going to throw the same exact symbol on the left here, and then instead of putting a 5 here, you'll put a negative 5, okay? That's it. That's how you set it up, okay? So you're just going to throw the same exact symbol over here, and then the opposite number. And then you just solve it from the middle. It's very important to understand that you solve it from the middle. What I mean by that is you're going to be subtracting 3 here, but you got to do it to all sides, the left, the middle, and the right. And then this is going to be negative 8 is less than x. We just have an x in there. It's less than 2. Okay, so yeah, so we got our little inequality there. So then for this guy, just graph it, put your little things on. You got negative 8 and you got 2. Now again, read it from the middle, okay? These are both open circles since there's no equal to. So read it from the middle. So x is greater than negative 8. So greater than negative 8 is like that. And x is less than 2, like that, okay? So that is your answer. So your interval notation here would be negative 8 to 2. Number 2. Alright, when you see a problem like this where, you know, you have a polynomial here with this, with this inequality symbol, the first thing you always have to do is you have to factor, okay? And how I show my students how to factor it is, I didn't used to show my students this little, I guess, X method. I don't know what you really want to call it, but I quite like it. So what you do is you're going to put this negative 10 up in this little area, and then you're going to put the 3 here, down here, okay? Then you have to say what two numbers here and here multiply to negative 10 but add to a 3. Well, 5 and 2, but has to be a negative 2 because 5 times the negative 2 is negative 10. 5 minus 3 is, 5 minus 2 is 3. So that being said, you just plop those guys down. So you got x plus 5 from this guy, and you got x minus 2 is less than or equal to 0, okay? Then after it's factored, first step is always factor, okay? After it's factored, you have to find what's called your critical numbers. Okay, your crit numbers, okay? And how you do that is you just set each of these to 0. X plus 5 equals 0, and x minus 2 equals 0, and solve each of them. So you subtract 5 from this guy from both sides, x is equal to negative 5. In this case, you add 2 to both sides, x equals 2. So your critical numbers is negative 5 and 2. So you just plop this on a number line, okay? You just got to put these two guys here, negative 5 and 2. Just make sure they're in order. Now, look at this thing here. You see how it says equal to? Well, that's going to mean both of these guys are filled in circles, okay? Now, what you got to do is you got to test points, okay? You got to test this section, and this section, okay? So what I do is I like to pick negative 100 over here just because to me it's blatantly obvious what the answer is going to be. If you stick negative 100 into this little part here, is this going to be a negative or positive number? Well, negative 100 plus only 5, you're going to have a negative number. Multiplied by, stick negative 100 in here, also a negative number. Negative 100 minus 2 is negative 102. So a negative times a negative is a positive. So this section, negative infinity to negative 5, is a positive. Now, it's always going to alternate, okay? Like I said in the very first problem which we did, which was number 3, I believe, it doesn't always alternate, but for your class it should. Okay, your class it should alternate. And just in case, if you don't believe me, again, just check it. In between here you could pick 0, okay, and over here you could pick something like 5 or positive 100, okay? Now, with that being said, what you have to do is you go back and look at the original equation here and you say, okay, original inequality rather, what does this symbol say? It says we're looking for numbers that are less than or equal to 0. What kind of numbers are less than 0? Negative numbers. Negative numbers. So you just go down to your number line and you just fill in the little negative section there. And now since these are filled in circles, now you got to do what's called interval notation. Negative 5, it begins there, and it goes to 2. And these are both brackets because they're closed circles. And that's number 2. Number 7. Okay, so when you see something like this, hold the urge to FOIL or distribute. The reason is because you have this minus here, okay? So what you're going to want to do is you're going to want to distribute just the negative, and there's always an invisible one here, so you're really distributing a negative 1, okay? If you just have a negative there, it's really a negative 1. So what you're going to do is you can drop the parentheses on the first guy. The reason is because there's no number in front to distribute, and when you don't really need to distribute anything, you can just drop it. So 6 plus 12i. So negative 1 times 5 is negative 5. Negative 1 times a positive 5i is going to be negative 5i, okay? Now what you got to do is you're going to combine like terms. Well, the numbers are like terms, and then the things with the i's are like terms. So what's 6 minus 5? That's 1, okay? So we're done with those. Check mark. 12i minus 5i is going to be a positive 7i, and that is the answer. On to number 8. Okay, so the directions for this is just going to be solve. Okay, so with that being said, when you have a square root in an equation like this, the first thing you have to do is you have to get that square root all alone on one side. And so in this case, this 2 here is causing a problem, so we have to subtract that guy to the other side and cross that off, okay? So you're going to have the square root of 3x plus 22 equals x minus 2, okay? Now, once that square root is all by itself, what you have to do is you have to get rid of it, okay? So how do we get rid of a square root? Well, you square both sides, and this 2 and that square root are going to kill each other. So we have 3x plus 22 equals this guy, because remember you have to square this whole side like I did here. So what that really is x minus 2 times x minus 2, okay? You have to do that because the reason is because you're going to ultimately end up having to FOIL this guy, or distribute is what I like to call it. Okay, so we have 3x plus 22. Now we're going to distribute this guy. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. Negative 2 times a negative 2 is a positive 4, okay? Then what you want to do is you want to start, you can combine those as like terms. So we have 3x plus 22 equals x squared minus 4x plus 4, because negative 2x minus 2x is negative 4x. Now when you have an equation with something that has like an x squared in here, you have to get this guy equal to 0, okay? And so what you're going to do is you're going to subtract 22 on this side, subtract 22 on that side, so that'll go away. And you're going to subtract 3x here, and you're going to subtract 3x here. So everything over here went away. So we got 0 equals x squared, negative 4x minus 3 is 4, 5, 6, 7. So we have negative 7x. And then this is going to be a negative 18, okay? 4 minus 22 is negative 18, okay? So what we have to do again here is factor. So hopefully you watched the other example where I did this guy. We're going to stick the negative 18 here. We're going to stick this middle number down here, negative 7. And you say, okay, what two numbers here and here multiply to give you negative 18 but add to negative 7? Okay, well we know 9 and 2. But in this case it has to be a negative 9, because negative 9 times 2 is negative 18. And negative 9 plus 2 is negative 7. So yeah, so we got 0 equals x minus 9, okay, from this guy, and then x plus 2 from this guy. Now you just set each of them to 0. X minus 9 equals 0, x plus 2 equals 0, and solve each of these guys. So you got plus 9, x equals, well I guess we don't really need that positive there. X equals 9, and you subtract 2 here, subtract 2, x equals negative 2. Now these are our answers. Now we're not done yet, because when the original problem starts with a square root, when the square root's involved, you have to check your answers, okay? So what you're going to do is you're going to take these guys and you're going to plug them back in. So this is our check, okay? So we have the square root of 3 times 9. All I'm doing is I'm taking my 9 and I'm plugging it into the x's, okay? So we have 3 times 9 plus 22 plus 2 equals 9, okay? We just basically, you know, hope this guy works out. So 3 times 9 is 27 plus 22 plus the 2 outside equals 9. This is going to equal 49 plus 2 equals 9. The square root of 49 is 7. 7 plus 2 equals 9. 7 plus 2 is 9 equals 9. Boom. So when you get something like this, we're happy, right? Gotta draw happy face here. Alright, so when you get something like 9 equals 9, that's good. That means this is definitely a solution, okay? So now we gotta check our next one. -2. So you do the same exact thing, but with a different number. So you have the square root, 3 -2 plus 22 plus 2 equals -2. Okay, all I'm doing is sticking my -2 into the x's here, because that's one of our solutions we're checking, okay? So the square root 3 times -2 is going to be -6 plus 22 plus 2 equals -2. -6 plus 22 is going to be the square root of 16 plus 2 equals -2. Square root of 16 is 4 plus, make sure you can see this, 4 plus 2 equals -2. So 4 plus 2 is 6. 6 equals -2. Now, does that make any sense? No. 6 can never equal -2. It does not equal. So you just go up here, cross that guy off, and your answer is only x equals 9. Number 9. Alright, so again, this is just going to say solve, okay? So when you see a quadratic here with something with an x squared, okay, and it equals 0, there's only a couple ways you can solve this. Either factoring, quadratic formula, or completing the square. So these are my rule of thumb. If there's no number here, try to factor it right away. If it doesn't factor, then you don't really have a choice. But always try factoring first, because factoring is the easiest and it's the fastest, okay? If there's a number here and the numbers look all complicated, it might be quicker to just use the quadratic formula, okay? But in this case, let's just see if this guy factors. Okay, so we're going to go over here and do our little x thing. You're going to put the 28 here. You're going to put the 11 here. And you say, okay, what two numbers multiply to give you 28 and also add up to 11? Well, 7 times 4 is 28, and 7 plus 4 is 11. So it's pretty straightforward. So we have x plus 7, and then x plus 4 equals 0. Set each of these guys to 0. X plus 7 equals 0. X plus 4 equals 0. And just solve them. -7, -7, x equals -7 is one of our answers. And then you're going to subtract 4 from both sides here. X equals -4. So your answer is just going to be x equals -7 and x equals -4. Number 10. Alright, so check it out. Kind of what I was saying in problem number 11 about how if there's no numbers here, just try factoring it right away. In this case, there's numbers here. There's a 29. There's -20. These numbers are kind of ugly. And again, the directions will just be solved. That being said, when the numbers are real ugly, I usually just jump to the quadratic formula, okay? So this is something you will have to have memorized. And that being said, the quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. And it's going to be x equals that, okay? So over here, this is our a, this is our b, this is our c. So a is going to equal 4, b is going to equal -20, and c is going to equal 29. Okay, so now knowing that, we just go to this formula, we just plop everything in. So x equals negative times a negative 20, which is b, plus or minus the square root of negative 20 squared minus 4 times a times c, which is 29, all divided by 2 times a, which is 4. Okay, so we got this big ugly mess here. So let's just slowly begin to reduce this guy. So we have x is equal to a negative times negative is a positive 20 plus or minus the square root. Well, 20 squared is going to be 20 times 20, which will be 400, minus, well, we got 4 times 4, which is 16, times our 29, okay, all divided by 2 times 4, which is 8. Now we have x equals 20 plus or minus the square root of 400 minus whatever 16 times 29 is. And again, just go off on your paper and just multiply it. I'm just going to pop in the calculator real quick just to save time. 16 times 29. But again, you need to know how to do that by hand. Just go over 29 times 16 and just multiply it out, okay? So 464. So if you did that by hand, you would get 464. Divide that guy by 8. We have x equals, I know it's kind of a long process, but I'm doing it step by step just so hopefully everyone can follow along. Now 400 minus 464 is going to be a negative 64. You take that guy and divide it by 8. X equals 20 plus or minus. Now, what do we do with this negative here? Because we can't really have negatives under the square root. When you have a negative under the square root like that, it just comes out as an I. Okay, a negative under the square root is an I. And now you can take the square root of 64, which is going to be 8. So the square root of negative 64 is going to be 8i. And you divide that by the 8 here. Now, we can reduce this guy. You can reduce them all by 2. So 2 goes into 8 4 times, 2 goes into 8 4 times, 2 goes into 20 10 times. Now, one note is you can only do that if all 3 of these numbers here can reduce. All 3 of them, okay? Now you got to do that again. 2 can go into 4 twice, 2 can go into 4 here twice, and 2 can go into 10 5 times, okay? So what are we left with here? Well, we have 5 plus or minus 2i divided by 2. Now, we have to break this guy up now. So how you break it up is, we'll just take it over here. Kind of a long problem, I know. We're going to have x equals 5 plus 2i over 2. And then we'll have x equals 5 minus 2i over 2, okay? And then you just break this up. 5 over 2 plus 2 over 2i. And then x equals 5 over 2 minus 2 over 2i. And then you can reduce this once more because 2 over 2 is 1, okay? Running out of room. 5 over 2 plus I. And then here we have 5 over 2 minus I. And those, my friends, are the answers to this problem. So we'll take a look at it one more time. These guys, okay? And if you didn't follow anything that went on in here, just rewatch this video. This is probably one of the longer ones so far, but you got to understand it and make sure you memorize the quadratic formula. Number 11. Alright, so check it out. The trick to these guys, again, the directions will just be solved. When you get some crazy exponents up here, like the only exponents we really like to work with are squared, x squared, or just for instance x. Okay, when we get some crazy stuff, fractions or negatives, some crazy stuff up here, we know this is going to be a u sub. So you have to say let u equal something. Well, you always are going to let u equal this guy right here, okay? Always is going to be that middle guy right here without the number. So you let u equal, in this case, x to the 1/3. When that happens, when you do this u sub, it will always break down this way. You'll have u squared here minus 4u minus 21 equals 0. It'll always break down into a form that we understand, we know how to solve, okay? With that being said, I'm just going to factor this guy. I'm going to take negative 21, put it there, negative 4, put it here, and let's see, 7 and 3, negative 7. Okay, negative 7 times 3 is negative 21. Negative 7 plus 3 is negative 4. So we got it factored. So we got u minus 7 times u plus 3 equals 0. You set each of these guys to 0. U minus 7 equals 0. U plus 3 equals 0. Add 7. U equals 7. Cool. Minus 3 on this guy to both sides. U equals negative 3. Now, are we done? No, we're not. Why? Because we got u's. We don't want u's. We want x's, right? Alright, so that being said, we just take what we did here and we sub it back in. So we have x to the 1/3 equals 7 because u used to equal 1. I mean, we let u equal x to the 1/3. So now we're putting x to the 1/3 back for u on both of these guys. So we got x to the 1/3 equals negative 3. Now, so we got to finish solving for x. So what you do here is you're just going to cube, both sides. And because what's going to happen is that's going to kill this exponent here. So you'll be left with x equals 7 cubed is going to be 343. And then negative 3 cubed is going to be x equals negative 27. Okay? And if this didn't make sense to you, think of it this way. X to the 1/3 equals 7. X to the 1/3 is the same thing as the cube root. The cube root of x equals 7. How do you kill a cube root? By cubing it. Okay, so x would equal 7 cubed, which is 343. And you do that same thing for this guy here, and these are your answers. Number 12. Okay, so now we're getting into some graphing. Fun, right? Yay! Alright, it's not that bad, I promise, especially these guys. The first thing you got to do is you got to identify what type of graph this is. This is a circle, okay? The reason this is a circle is because you have both of these guys are squared. You got an x squared and you got this y squared. And it's addition here, okay? That equates to a circle. So for a circle, all you need is a center and you need a radius. Your center, you just get from these guys, okay? If you just have an x squared here, just simply an x squared by itself, the x part of your center is 0, okay? To find the y part, you just look here, and it's always the opposite of this guy here. So since this is y minus 3, it's going to be a positive 3. And that's it. Boom, that's your center, okay? Your radius, you always look at this guy here, this 36. In this case, it's a 36. And you're basically going to ask yourself, what squared gives you 36? Well, 6 squared would give you 36, so your radius is 6. And that's all you need. Now you just do the fun part. You just graph it. Okay, so you start at your center, which is 0, 3. So 1, 2, 3. This is your center, okay, right there. and your radius is 6. So you're just going to go 6 in every direction. 1, 2, 3, 4, 5, 6. Put a little dot. You're going to go up 6. 1, 2, 3, 4, 5, 6. You go this way 6. 1, 2, 3, 4, 5, 6. And then you're going to go down 6. 1, 2, 3, 4, 5, 6. And then it's just like you're in kindergarten. You connect the dots. Okay. And you got your circle. Number 13. All right. Again, graph. Okay. So this guy is going to be what's called a hyperbola. Now, how do I know that? Well, both of these guys are squared. You have an x squared and you have a y squared. They're both divided by a number, okay? And it has to equal 1, okay? So this is the form. But the real clue is this negative here. This negative tells me it's going to be a hyperbola, okay? So remember that. Now, all you got to do is you really got to find the center of your box that we're going to draw, which I'll show you. And you got to find your A and your B, okay? Your center. Again, just like the circle, you just look at your x's and you look at your y's. In this case, it's just simply an x squared and just simply a y squared. 0, 0, okay? Your A, you look at the thing under your x and you say, what squared gives you 4? Well, 2. What squared gives you 9? 3. Alright? Now that's it. We just got to go graph it. Right? Alright, so your center, nice, 0, 0. Your A has to do with your x. So what you're going to do is you're going to go 2 on each side of your center in the x direction. And there's 3 we got from underneath of our y. So you're going to go 3 up and down. 1, 2, 3. 1, 2, 3. And what you do is you're going to draw a little box. Just make sure that your box is dotted, okay? Now what you do, once you got your little box, you draw asymptotes, okay, through the corners of the box, okay? So just follow this process and it's going to work every time, okay? Now, once you got your box and you got your asymptotes, the next thing you got to do is you got to look at this guy right here, okay? You got to say what's first. What's the positive guy? In this case, it's x, okay? Since the x is positive, what you're going to do is in the x direction, okay, you're just going to draw your graph like that. Because this is the x-axis, this is the y-axis. The x-axis, apologize, that is my office phone, okay? So, and that is that. So it's going to open up in the x direction. Alright, and that is the graph. Number 14. You guys ready for more graphing? Alright. Cool. The quality of this guy. You see, this looks exactly like this problem, okay? Exactly. Same number, same everything, right? It's the same freaking problem. Well, there's one. Can you spot the difference? We're going to play one of those games like, can you see the difference? You have a negative in this guy, and that was the clue to say that this was a hyperbola, okay? This is a plus. So plus is the same thing, but when it's a positive in front, or in the middle, I'm sorry, it's going to be an ellipse, okay? So you do the same thing. You find your center, and you find your A, and you find your B. Your center, again, same thing, 0, 0, because when it's just an x squared and a y squared alone, no numbers around it, it's just 0, 0. A is 2, and B is 3, because we got the 2 because 2 squared is 4, and we got the 3 because 3 squared is 9, okay? And you just come over here and graph this guy. Alright. Now, you graph your center, okay? And in this case, in the A, remember the A we got from our x here, from underneath our x. So you're going to go 2 left and 2 right from your center. And then your B is 3, 1, 2, 3. So that's going to go up and down, okay? And what you can do is just kind of plot some points there, and then once again you're gonna draw this guy, but in this case it looks like that, kind of like an egg. Like, I'm not a very good artist apparently, but just you know, make sure that this guy's rounded. Do not draw it like a diamond. Do not. Wrong. Don't do that, okay? Draw it like an egg. Like, you know, it looks like an egg, but technically it is an ellipse, alright? And that's number 14. Alright, number 15 and 16. So I'm going to kind of do these in one section here because they're both very related. So, the question is this a function or a one-to-one function? Okay? So, the first thing that you have to do is these problems are very straightforward, because to determine if it's a function, all you do is look at your x values here, your x, the 5, the 9, the 25, and the 16, and do any of them repeat? Meaning, are there 2 5s or 2 9s, etc.? No, they're all very unique numbers. That being said, it's a function, okay? Like, that's it. If none of the x's repeat, it's a function. So to check if it's one-to-one, all you do is you look at the y's. Do any of the y's repeat? 10, 4, 5, and 100? No, they don't. So in this case, it is a one-to-one function. Like, that's it. Okay? Number 16. Same exact question. Is this guy a function or not? Well, all you got to do again is look at the x values. Okay? 1, 3, 4, and 3. Now, do any of the x values repeat? Well, you have a 3 here and a 3 here. So they repeat. With that being said, it is not a function. Okay? And that's that. Okay, we are on number 17. Man, this review is long. Well, let's just keep going. So we have 4 questions here: A, B, C, and D. Now the question is, like, there's no directions on this thing, but I believe the directions are: is this guy, are these graphs functions, and are they one-to-one? So if you want to check if it's one-to-one, okay, if it's a one-to-one function, you got to check the horizontal line test. And if you want to know if it's a function, you do the vertical line test. Okay? So, excuse me. So, you just check, you know, you basically just draw an imaginary line, you know, on all different spots, you know, on this graph. And this is going to be the horizontal line test. You're just imagining a bunch of lines going left and right through this graph. If it hits more than once, for instance, it hits here, here, and here, so it hits in that one line 3 times, it is not one-to-one. Okay? Excuse me. So it's not one-to-one, but is it just a function? So you can imagine now you're doing the vertical line test, up and down, and it hits here, it hits here, it hits here. There's no spot, you know, vertically that this graph, it gets hit more than once. So it's not a one-to-one function, but it is a function. Okay? So it is a function, but it's not one-to-one. Okay? And that's it. So we're just going to do that for all of these. So B. Okay? So you do the horizontal line test and the vertical line test. And you notice it hits horizontally there and there. And it hits more than once vertically as well. So it is neither. Okay? I'm just trying to save time. You're not going to write neither on your test. You're going to write it's not one-to-one and it's not a function. Okay? C. Well, you tell me, is this guy 1 to 1? It's not, because it gets hit twice. So not 1 to 1, but if you have, lines going up and down, it never hits more than once. So it is a function, just not a 1 to 1 function. Okay? This guy. Imagine lines going left and right. Awesome. It never hits this line more than once. It never hits the actual graph here more than one. So it is 1 to 1. Check. And is it a function? Yes, it is, because it never hits these vertical lines more than once. So it is a function. Yeah, I probably need to work on my jokes. Alright, anyways, that's it. So in order to determine if it's a 1 to 1 function, you just do the horizontal line test. You just imagine horizontal lines going through it. And a function, you just check the vertical line test. So you just check up and down and see if your graph hits more than once. If it does not, then it's a function. Alright, number 18. More graphs. So we want to know what's the domain and the range. Okay? Now, the thing is, one of my students just gave me this review, so I'm not 100% sure if they just give you the function and they make you give the graph, or if they also give you the graph, because these are both on her review. So I'm not sure if she just, she has notes, they just gave her the function and she had to figure out the graph. In any case, I'll make sure that you guys understand these, okay? So, domain and range. Well, the domain is your x values, okay? And your range are always your y values, okay? Excuse me. That being said, what you have to do is you do have to understand. So even if they just gave you, the function, you do have to know what square root graphs look like. And they look like the shooting star guy. It's a shooting star. In this case, an absolute value function. Absolute value functions, if there's an absolute value in the problem, it will always look like a V. It'll always make that V shape, okay? And then for this guy, if a log will always take this shape, okay? Always. Now, that being said, what you do is to find what we're going to call your starting point in this guy. Your starting point for your graph. It's going to be, you see this inside this radical here? You have this -1. To find your starting point, it's always going to be the opposite of what's inside here. So opposite of -1 is 1, comma, what is out here, okay? So -2. So opposite of the inside, and then it just takes this guy. So that's your center, and that's where they got this point here, 1, comma, -2. Now, if you know that, you know the starting point, and you know what the shape looks like, because as a square root, you just draw that guy, and it's gonna be very easy to do. Okay, so your domain is x values. So you always want to look where where does this guy start at? Well, it starts at 1, and it's gonna be a bracket. This is your domain. It's gonna be a bracket because we do start there. Okay. And now where does this graph go to? Well, this graph continues to go forever, for infinity. It just keeps going and going and going, kind of like the Energizer Bunny, right? So there you go. So your domain is going to be from 1 to infinity. Okay, now your range. Remember, your range is y value. So instead of looking left and right, you're looking what's the lowest point. The lowest point on this graph, it goes down to -2 here. Okay, so that again is included, -2 to, where's your graph stop at? Well, it just continues to go up and up and up and up and up forever. Okay, so -2 to infinity. And that, my friends, is your domain and range for that graph, okay? And if none of that made sense, because I know I'm going a little faster than usual, but if you have any trouble with that, just re-watch this and you'll definitely get it. I promise, okay? So this guy, again, to find your, your whatever you want to call it, to find the lowest point here, the little cusp, the cusp of the V, what you're going to do, again, is it's going to be opposite of what's inside here. So -2, comma, and then exactly what's outside. So if it's inside the parentheses, or the absolute value guy here, it's going to be opposite. So instead of a +2, it's a -2. And then this -5, you just plop right there. And that's this point here. That's how we got that. So -2 down 5, okay? And then since it's an absolute value, you know it just has to be a V. So you just, boom, plop that guy. You just doom, okay? So it's very important and very helpful that that you know what these graphs look like beforehand. All right. Okay, so domain, again, it's x values, and you got your range. So domain, in this case, it just keeps going left forever, and it keeps going right forever. Left and right is our domain. So it just goes -infinity to infinity, okay? And your range, remember, your range is up and down. So what's the lowest point on your graph here? Your lowest point is, this is -5, so it's, and that's included because we're actually at -5, -5, 2, and it just continues to go up forever. And that's your domain and range, okay? This guy right here. So we're going to do our domain, we're going to do our range, okay? So, that being said, log, again, you got to know what this guy looks like. And this is just log, like it's just simply a log. So you're going to have your vertical asymptote at 0, and you're just going to graph it, okay? In this case, there's nothing special about it. Like, as long as you have the log graph memorized, you just plot it down, okay? So again, have your graphs memorized. I can't stress that enough. So your domain are x values. So x is left and right. Where does it stop at? Or where does it begin? I'm sorry. Begins at 0. But the reason in this case is parentheses, because your graph, it approaches 0, but it never actually gets there because of this asymptote. So that being said, we got 0. So it goes from 0 to, your graph just continues that way forever and ever and ever. So 0 to infinity. Range is up and down, okay? And in this case, it's just going to be -infinity to infinity because the graph shoots down forever. It just continues to go down, 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 and it continues to go up, 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 up for eternity, okay? And that is your domain and range of f of x equals log base 2 of x. All right, number 19. So it just says find the inverse, okay? So your very first step, there's a process to this. Your first step is change f of x to y, okay? So we have y equals 2x minus 7. Your next step is just flip the x's and y's. So wherever there's a y, you put an x. Wherever there's an x, you put a y. So we have x equals 2y minus 7. Now, just simply solve for y, and you got your inverse. So add 7 to both sides. We have x plus 7 equals 2y. Divide both sides by 2, and we got x plus 7 over 2 equals y. And that's your inverse. So you're just going to want to change this y into inverse notation, which looks like this. So it's going to be f with the little -1 up here of x. This means f inverse equals x plus 7 divided by 2. And that's how you find the inverse. Same process for every problem. Alright, number 20. So same direction, try to find the inverse. This one's going to be a little bit harder, but again, same process. So change your f of x to a y. So we have y equals 2x minus 1 over 3x plus 2. Now you're just going to flop all of your y's and your x's. So wherever there's a y, put an x. Where there's an x, you're going to put a y. So you got x equals 2y minus 1 all over 3y plus 2, okay? Now what you're going to do is you're going to cross multiply, okay? Cross multiply these guys. So if you cross multiply here, you're going to have x times 3y plus 2 equals, well, 2y minus 1 times 1. Anything times 1 is just, you know, that thing. So we got 2y minus 1. Okay. Now what you're going to want to do is you're going to break this guy out, because you see we're solving for y, but there's a y inside here and a y over here. So what we got to do is we gotta unlock this y here. It's in jail. It's in those parentheses, so it's stuck. We got to break it out so we can eventually combine those y's. So we're gonna have 3xy plus x times 2 is 2x equals 2y minus 1. Now you got to get everything with a y on one side and everything that does not have a y on the other side, okay? So what we're going to do is we're going to subtract the 2x to this side. So we're going to cancel that off, okay? And we'll just do it step by step. So we got 3xy equals 2y minus 1 minus 2x. Now we want to get this thing with the y over here with the other y over here. So we're going to subtract 2y here, subtract 2y here. So on the left side, we're going to be left with 3xy minus the 2y we just subtracted equals negative 1 minus 2x. Okay? Now, what you're going to do is, you see, now we have a y here and a y here. So you can't just subtract these because there's an x here, which kind of messes that up. So what you got to do is you got to extract that y. So you're going to pull it out, and what you're going to be left with is just a 3x here minus the 2 here. And if you're not, you know, sure if you did it right, you can just multiply it back in and you should get this. Y times 3x is 3xy minus 2 times y is negative 2y equals negative 1 minus 2x. Now you're just going to divide the 3x minus 2 to both sides. 3x minus 2. I'm going to try to get fancy here and have some multi-colors going on. That guy cancels out, so you're left with y equals negative 1 minus 2x over 3x minus 2. And that is your inverse. Again, at the end, you're just going to use a little inverse notation here. And that is your inverse. So this problem was a little bit trickier. It probably will be on your final though. So really understand this problem again. If that was a little bit too fast, just go back over it again. Go over your notes. You should be taking notes with this video. That's how you're going to optimize your studying, okay? Do these problems with me, okay? Don't just watch me do them. And I think you'll really understand what's going on. All right, on to number 21. Number 21. Okay, so the directions for this guy are just solve, okay? So it's going to be solve. Okay, so the trick to this guy is whenever you see x's in the exponents, okay, x's in the exponents, you know there's probably going to be, you know, logs involved, okay? So what you want to do is you're going to need this number and this number to match, okay? And they can't exactly match, but what I mean is they both have to have, you know, basically, like, they both have to have a big number with an exponent like that, okay? Because they have to match in order for this to work. So what you have to notice, you have to say, okay, is there any way I can change this to something with an exponent and this to the same big number here with an exponent? Well, in case that doesn't make sense, let me just show you. So 8, you know, is 2 cubed. So you have 2 cubed to the x. We just rewrote this 8 as 2 cubed equals 16 can be written as 2 to the 4th. And we still have 3x plus 2 up here. Now, this is what I mean. The big number here, both of those guys have to match, these 2's here. Now, the exponents don't have to, but this is the key right here, is get those guys to match, okay? So hopefully that makes sense. So now what you're going to do is you're just going to multiply these exponents. So you got 2 to the 3x equals 2 to the 4, but then parentheses 3x plus 2. So we just basically did this, okay? Now, what you can do once these guys match here, what you're going to do is you're going to take a log base 2 of both sides, okay? Log base 2, because what this does is it's gonna kill these big 2's here, and you'll be left with just 3x equals 4, 3x plus 2, and you just solve it, okay? So first thing you got to do is you got to distribute that 4. So we have 3x equals 4 times 3 is 12x plus 4 times 2 is 8. And then what you got to do is you got to get all your x's on one side and your number on the other side. So we're just going to subtract 3x here, subtract 3x here, and at the same time we're going to minus this 8 over here. So we're going to have a negative 8 on the left side, okay, equals, well, it's 12 minus 3 there is going to be 12, 11, 10, 9. So we got 9x, divide both sides by 9, and there we go. X is going to equal negative 8 over 9. And that is it, okay? Now, I know this problem is probably a little tricky. The trickiest part is noticing this 8 and the 16, you have to change them to where these big numbers here match, okay? And that's where a little bit of ingenuity comes into play. You got to be able to figure that out on your own, okay? And it shouldn't be too difficult, you know. You just got to say, what can I change this to and this to get these two big numbers here to match, okay? And that is your answer. All right, on to number 22. Okay, almost done here. We just got one more problem after this. So if you stuck through this with me, congrats, because you're probably going to do very good on your final. Okay. So, again, same directions are solved. Okay, what you got to do, you see, when you have two logs like this and they're being added together and it says solve, the first thing you got to do is you have to combine those into a single log, okay? And how you do that is, if you recall, if you're adding two logs together, addition goes to multiplication. That being said, you're going to have just one log base 2, but now you're going to multiply the insides here, this 8 and this x. So you have 8x, okay? So log base 2 of 8 plus log base 2 of x can turn into just log base 2 of just 8 times x, and it's going to equal log base 2 of x minus 2. And now, since you just have one log on the left, one log on the right, it's very nice because this base here, so this base is a 2, you just put a big 2 there and a big 2 there, and what happens is those cancel out. So you're just going to have 8x equals x minus 2. Just solve for x, and you're good to go. So subtract x here, subtract x here. So we're going to have 7x equals negative 2. And then divide by 7 on both sides. X equals negative 2 over 7. Now, are we done? Definitely not. Whenever the problem starts with a log, you have to check your answer. So you go up here, or you go down here rather, and this is a negative 2 over 7. So the only issue is you're not allowed to have negatives in the log. So this is just a number, so we skip that. Now you got to check here. If you stick a negative 2 over 7 into this x here, are you going to have a log? Are you going to have a negative inside of your log? Yes, you are, because you're going to end up with, do a little note over here, log base 2 of negative 2 over 7, which you cannot have a negative inside the log. That is a big no, okay? That being said, your answer doesn't work, so your answer is no solution. And that is your answer. So remember, with logs, you have to check them at the end, and you cannot have a negative inside the log. So in this case, the answer is no solution. Alright, we're on to our last problem of this review, number 23. Okay, so this would be a word problem, and it's going to say something like, you know, how much money will Amy have after 1 year with a rate of 2% if she started with $4,000 and it's compounded semi-annually, okay? So that's what it's gonna read. I don't actually have the word problem written down on this review, but it's gonna read something like that. This is a formula you gotta know here, okay? This formula is it's what you gotta know. So when it says semi-annually, okay, that's gonna be your n in this formula. So n is gonna equal 2, since semi-annually means twice a year. Your time is gonna be 1 year. Your rate is going to be 2%, but we need to write that as a decimal, so it's going to be 0.02 for our rate. And then our principal is P. Our principal is the money that we started with. So we gave, you know, the bank or whoever, the hedge fund or whatever, we gave them, or the mutual fund, $4,000 to start with. How much money are we going to have, okay? So you just start, you know, just plug it in. So we got A, because A is the amount after, and that's what we're looking for. So we have A is going to equal your principal, which is 4,000 times 1, I'm just using this formula here, plus our rate is 0.02 divided by our n, which is 2, and yeah, and then your rate, your r here, actually that's not supposed to be r, that's supposed to be n, she has her formula wrong, it's going to be to the nt, so n is 2 times t is 1, okay, so make sure this formula is correct on your thing. It's P is 1 plus R over N to the NT, okay? So now, in this class, you cannot use your calculator, so you're just going to have to work this guy out, you know, one at a time. So 1 plus 0.02 divided in half is just going to be 0.01. 2 times 1 is 2. I'm trying to go quick because my battery and my camera's about to die. I got about 4 minutes left. So then, equals 4,000. 1 plus 0.01 is going to be 1.01 squared. Okay, so now what you would have to do is you have to go off and do this on the side. Okay, so 1.01 squared would be 1.01 times 1.01, and if you do that by hand, which you should be able to do multiplication of decimals by hand, you're going to end up with 1.0201. Okay, so you got 4,000 times 1.0201. If you put that in your calculator, or I'm sorry, if you did that by hand, you'd end up with $4080.4, and that is your answer. I apologize, it's a little rushed, but my camera's just about to die. It says I have 1 minute left. So again, do all this work by your hand, and that is your answer.